Hey CNC Woodworkers, this video is how to do VCarve inlays with Autodesk Fusion. The goal is to create tight wood inlays with zero gaps, but this concept will also work if you're doing an epoxy fill inlay or if you're just leaving it as a plain engraving. This video is mainly about how to do 2D inlays, but the plugin I wrote will also create inlays on curved surfaces, something that's very difficult to do in other software. First, I'll talk about the design process in Autodesk Fusion, including how to create the correct CAM and manufacturing toolpaths. I'm going to be using a new plugin I wrote, but you don't have to use this plugin, and at the end of the video, I'm going to explain exactly what the plugin does in case you don't want to use it. Next, we'll jump into the shop, and I will talk about how to dial in the inlay fit so you don't have any gaps on the side or underneath the bottom of the inlay, which is very important. Let's jump into Fusion and get it started. Let's start with the 2D inlay. So I'm going to go ahead and show my origin. I'm going to select the XY plane, and I'm going to go ahead and click on Create Sketch. Now, it didn't automatically look at Sketch because I have Auto look at Sketch turned off in my settings. So I'm going to go ahead and hit Look At to view it from the top. And I'm going to hit R for rectangle. I'm going to snap to the origin. And let's do a depth equals 15 inches. Hit Enter. And let's also select this bottom line, hit D to hit a parameter. And let's make the width equals to 20 inches. And this is just creating parameters automatically for us, which is really nice. And so there's my basic shape. I'm going to finish the sketch. Let's go expand the sketch and let's name it Basic Shape. I'm going to select that profile, E for extrude. Let's extrude it 1.5 inches. And let's go ahead and hide the origin. So here's our basic shape. Let's go ahead and give it a name. Let's call it cutting board. And ideally we would create components, but I'm going to skip creating a component for simplicity at this point. And next, let's create a sketch for our design. The design has to be on or above whatever you're going to project it onto. So I'm going to select this top face of the cutting board, and I'm going to hit the Create Sketch button. Again, I'm going to go look at it, and I'm going to scoot over a bit. I'm going to go ahead and insert an SVG from my computer. I'm going to select Insert from my computer, and I'm going to find an SVG. I'm going to go ahead and drag it, rotate it. I don't know why Fusion treats SVGs a little bit strange with regards to their sizes and importing them. And we're going to hit OK. And finish sketch, and I'm going to name this sketch over here Design. So now we have a basic 2D shape that we want to project our inlay into. Now let's run the plugin. So I'm going to go ahead and select Create Inlay VCarve, and it flashed really quickly. And what happened is, if you haven't ever activated the manufacturing workspace, the plugin will flip to it to actually get the CAM data loaded and flip back. And in fact, let's go preload some stuff for this particular project. I'm going to go from Design to Manufacture. And I want to preload the bits that we're going to use. And this is just going to make things easier. You don't have to do this now, but you could do it after you generate the inlays. I'm going to hit the Tool Library. I'm going to go to Avid CNC. And the tools you can use for V-carving, really you could use an engraved chamfer mill, or you could use a tapered mill, and that's it. If you have your bits listed as something else, you're going to have to customize and modify them. And something to note too is if you want to use a pure V bit, like this is a pure V bit, I'm going to click Edit Tool. The cutter has to have a tip diameter. This one will not work. If you want to use a pure V bit, give it a really small tip diameter of like 100 thousandths of an inch. But I'm not going to use that one. I want to use my trusty Amana 15-degree V-bit. And something to note about this bit, the cutter is going to say the inclusive angle, the total angle is 15 degrees, but the taper angle is 7.5, and Fusion names it by that taper angle. So don't be confused. 15 degrees is the bit angle that we need to know for some things. I'm going to hit cancel. So I want to use this bit. I'm going to drag it from my tool cloud library to the document, the untitled one here. And I'm going to go back to my filters. I'm going to uncheck the filters to clear them. And I'm going to go to a flat end mill filter. And I'm going to do some clearance with a 1/8 of an inch spiral downcut. So I'm going to drag that bit also to my document. And then hit close. And again, you don't have to do that. It's just going to make things a lot easier and a little bit faster. So now I can go over to design. We can run the plugin with create Inlay VCarve. And it's going to pop it up again. No flashing this time. Now let's take a look at some of the options. First of all, we have a name. And so whatever the active component is, we're going to generate some subcomponents, and they're going to be named based off of this name. So let's call it Leo. Next, new component. So right now, I can either do two things. I could create a new component for the actual inlay and the pocket of the inlay. And what it's going to do is going to copy this guy into a new component. Or it could target and use the existing one. And I want to use a new component, so I'm going to check new component. Profiles. So I can go ahead and I could select any individual profile that I want to actually make for the inlay. Or I could go ahead and select the whole sketch on the side under sketches. Or you could individually select portions that you want, and I'm going to go ahead and do that. I want to do this part here and this little bit here. All right. Target planar face 2D. So you can either create a 2D or a 3D inlay. A 2D inlay is something like this, which we're doing right now. And I create toolpaths that are good for 2D and also do some simpler operations for the inlay itself. 3D is a little bit more complex for the operations, and the toolpaths are different. So that's what that option is. 3D will only let you select bodies. 2D only planar faces. Inlay depth, let's go to inlay depth of 230 thousandths of an inch. We want to create a plug and a surface gap, base plug thickness, flip the plug. I'll talk about these in a little bit and explain exactly what these are when we're going to actually do the machining. Speaking of machining, let's click on Toolpaths, and we want to create a pocket setup, and we want to create a plug setup. And since we preloaded in the document a V-bit, I went and selected the first V-bit I found and the first flat bit that I found. If you don't have any in your document, it will not be enabled, and you can explicitly set the tool angle that you want to use or the clearance bit diameter you want to use. These can easily be changed later via parameters, which I will show also in a little bit. And the same goes for the other features, the inlay depth, the inlay surface gap, the plug base thickness. All these are parameters that you can easily change after you create this inlay. So let's go ahead and select this top face as the target, and let's hit OK and let it do its thing. Let's take a look at what the plugin generated. I'm going to zoom out a little bit. Now, it's kind of hard to see what is happening, but we have 4 new components on the side, and let's color them to make them a little bit easier to see. I hit A for appearance, and I am going to go to my favorites. Let's go and find 3D Cherry. I'm going to click it and drag it over to the Leo pocket. Then I'm going to scroll down. I'm going to find 3D Walnut, drag it over to Leo Inlay, and then hit close. Now it's a little more obvious as to what we have. So first of all, since we created a new component, the original cutting board shape here was hidden. The design is also hidden. The pocket. So what is this? This pocket, if I go ahead and hide the inlay, is the thing that has the part that we will be engraving into. And the inlay itself is just the portion that goes into it from what you see when you're totally done with the whole project. Now, The inlay itself, this part here, is just purely ornamental. It's really just for you to get a look at the final design. I also do use it in some of the calculations. The other part of the puzzle is the plug. And so over here we have the plug. Kind of obvious that it's a mirror image. And some other interesting things about the plug is that we have another component called the plug stock. Now if I right click on the plug stock, I have the opacity control set really low, like 20%. And that's what you can see, this shaded area above the plug. So if I were to hide that, the plug stock is completely hidden. Now I can show it and you can see it on top. The plug stock is essential for machining the inlay correctly. And I will talk a little bit more about that in a bit. It's more essential for doing a curved inlay than flat inlays. Now, some things we can actually tweak on these settings, but I'm going to talk about that later. Let's take a look at the parameters that I generated. If you click on Modify, Change Parameters, you're going to see a whole bunch of new parameters that I added, which you can customize and change. So that inlay depth, you can go ahead and you could change it right here, and everything will dynamically update. The inlay fit adjustment is one of the most important parameters, and when we go and actually machine this, I will talk about how this comes into play. It is the one parameter you will tweak. You'll probably not ever have to change the inlay depth unless you want it to be deeper or shallower. The same goes for the plug surface gap, the plug base thickness. The inlay bit angle has to be kept in sync with the bit angle that you're using, and we already set that and picked that earlier. If you change to a 30-degree bit, you would need to go to the parameters and change it here. Otherwise, some of the math will not work out. Same goes for the pocket clearance tool diameter and plug clearance tool diameter. These aren't as important as the bit angle, and just things won't quite work as well if you don't have those in sync. Next, let's go and take a look at the manufacturer section, because behind the scene here, a bunch of work's been happening. And that's because we pre-selected our bits. Now I'm going to activate the pocket one first to look at it. And notice when I switch back and forth from plug to pocket, it hides everything else that's not relevant. And that's because I turned on a feature down here. I have Sync View with Active Setup turned on and Sync Visibility with Active Setup. I highly recommend turning these things on. It just makes it a lot cleaner when you're using Fusion. So let's look at the toolpaths I generated here, and let's see what's happening. So the first one is a VCarve outline using a 3D pencil toolpath. And what this does is it's going to do a V-carve around the outline, bring the bit up to nice sharp angles in tight corners. I'm going to double click on it to show some of the features on it. Now, if you didn't select a tool earlier, like I demonstrated, then you would have to pick the tool now, and the toolpath would be invalid. It'd have a red exclamation point next to it. I'm going to go to the Geometry tab and talk about the things that are important. The machining boundary is set to a selection, and the selection is a sketch, and the sketch is that basic shape, and it's really actually the inlay shape and maybe not the profiles that you selected. The tool containment is set to tool center on boundary, which is very important, and no additional offset. The rest of the settings aren't too important right now. I will talk about them later when we're actually machining. And next is the clearance bit. And so you can see the toolpaths where that 1/8 of an inch bit is getting out the larger areas and doing some clearance. Now, the trick about this guy here, if I go and double click on the tool to edit it, I go to Geometry. Again, it's limited to the sketch profile, but the tool containment is tool inside boundary, and it's got this very specific number for the additional offset. Now that number is actually an expression. So if I click the 3 drop-down dots here, I can go Edit Expression, and I can see that the expression is pocket stock to leave. So it's an actual parameter. So I'm going to go ahead and hit cancel, and let's go back to the design, and let's go and bring up the parameters. And I'm going to scroll down to the bottom, and one of the bottom ones is pocket stock to leave. And it's set to a special value, tangent inlay bit angle over 2, inlay depth, and that's how this is calculated. It's just some basic math as a parameter. And this is why you have to keep the inlay bit angle set to the correct thing. I'm going to go ahead and back to the Manufacture tab, and let's look at the last toolpath, the V-bit rest. And to emphasize what's happening there in the clearance bit, so since we're going to be staying inside the boundary and offset by the amount that the V-bit would leave, so we don't cut into the V-bit portion, that's essential, and that's the main trick for V-carving in Fusion. But there is another trick that you need to know of, and if you look in here, there are parts that the clearance bit could not get into, and we have to come back with a V-bit and finish that off. And that's what this V-bit rest is. And so I can double click on this and go over to the geometry, also limited to the sketch profiles. The things that are essential here, it's also set to, the tool containment is set to center on boundary since it's the V-bit, but the offset is, if I click the dots, edit expression, also minus pocket stock to leave. So it keeps it inside further than the actual V-bit would leave. The other part that's interesting is rest machining is checked on, ignoring stock less than 1 thou, and that will let it get all the rest that the other bits didn't get. So if you look at that toolpath, we can see it's generating little bits over here in all the parts that the clearance bit couldn't get. And so this order is not super fortunate because you don't want to have to probably do a lot of tool changes, and I'll talk about how to work around that when I discuss how to actually machine this. So let's activate the plug and let's see how it's doing. So similar to the other one, there's a VCarve outline, and it's just limited a little bit different. And let me talk about the limits a little bit more. So if I expand the models, and I expand the models, and we don't need to see this one or this one. So right now we're on the plug. If I expand the plug and expand the sketches, we have some special sketches in here. And one of them is the machining boundary. And so that's a sketch that I create that is the boundary of where the plug should be machined. There's another one that's the clearance boundary, which is a little bit offset, and that's for the clearance toolpath. So if I go ahead and click the first one here, the pencil operation, click the geometry. The sketch profiles for this guy here is set to the machining boundary. You have to double click on it. So the sketch selection is that machining boundary. And it's set to start inside, also kind of important. And we want it to be inside the boundary, V-bit, and that's going to leave a slight bit of material. The clearance bit, so again, if it has a machining boundary set to a sketch profile, if I double click on it, that sketch profile is a clearance machining boundary starting inside. And it just goes outside a little bit so it gets all the parts, and this is really more important when we're actually doing a 3D carve. It's not as important for 2D carves, even though I am actually using 3D toolpaths for it. And kind of like the pocket, the tool is set to inside the boundary by the additional offset. And again, this is another expression, and the expression is plug stock to leave. So if you update any of the parameters, the toolpaths automatically update without you having to go and tweak anything. It just works automatically. V-bit rest, like before, it's going to be the same type of thing, and the inset is tool center on boundary, and an additional offset of negative plug stock to leave. Rest machining from what was done before. So that's the basics on the toolpaths, but there's a real big trick to making the plug work correctly. And the way the pencil operation works is it's going to follow along and try and go as tight as it can to these profiles here. And we could actually see it doing that. But we want it to be a little bit deeper for being an actual VCarve inlay plug. And so that's where this has something special. So inside the setup, if I double click on Leo plug, the stock is set to this Leo plug stock shape or component that was created. And that shape, if I hit cancel and I look at that shape, kind of the yellow outline, let's hit the front, the yellow outline of the stock shape goes deeper. And so what happens is when we do V-carving, it's going to actually make it go deeper by that stock amount. And again, here's the main shape, the gray part, and then here's the actual V-bit carving where it's going to go deeper. And so my parameters just allow customizing the fit by changing how these all interact together. Now, before we jump into the shop, let's talk a little bit more about some of the details about this. I'm going to go back to design. Now, when you're making your board, we gave it a specific size. Your project has a specific size. And the plug size is it's just as big as it can be. And we may want to customize that size. Now, the plug position, I set flip plug when I selected the creation of it. And let's go ahead and see what happens if we don't flip it. So I'm going to revert the position up here. The plug's right on top. And I'm going to undo. And I'm going to go ahead and capture position so that I can save this plug location. Now let's change some of the parameters. I'm going to go to Modify, Change Parameters. And let's go ahead and let's make the plug backing a lot thicker. 1/4 inch seems a little bit weak. And so plug base thickness is what I'm going to change. That's right here. And let's make it a 1/2 inch. And so I'm going to hit enter and everything went and dynamically recreated. And now this base thickness is 1/2 inch. So it's really easy to tweak things. And one of the other things you may want to tweak is the stock size you're going to use for the plug. So again, that's a sketch which you can customize to the plug's the plug, Leo plug, expand it and expand the sketches. There's a plug profile sketch. If I double click on it, I can edit it. I'm going to go to the top view because I don't have lookout turned on, and the plug size tries to be as tight as it can be around your particular design. And let's make it a little constrained. We want to make some perpendicular constraints to make it always be a rectangle shape because we're going to be cutting it out of wood probably. And I'm going to hit escape and let's dimension it so that we can have some specific sizes. So I'm going to go select the bottom one, hit D for dimension, and let's make the plug stock width be 15 inches. Hit enter. Let's do the same for the other part. The plug stock depth to be 15 inches. And now we would start with the 15 by 15 piece of wood. And so I could kind of drag it and make sure it's around all our sketches. Hit finish sketch. And it's going to go through and recompute everything so that the plug is larger. And that plug profile is something that I expect you to probably modify. Now I'm going to talk about how to find the perfect inlay fit. Now, in theory, if you're creating an inlay that's 100 thousandths of an inch deep, that plug stock should be an extra 100 thousandths of an inch to perfectly fit into the inlay. But in practice, that will never work out. And the reason why is because we have a lot of variances. If you are doing things with a 15-degree bit versus a 60-degree bit versus a 30-degree bit, the fit may change. So the bit angle comes into play. The other thing is the type of wood and where you're doing it on the wood. So if you're doing a face grain to face grain inlay, your settings may vary. If you're doing an in-grain to in-grain, your settings may vary. And if you're doing in-grain into face grain, your settings may vary. So keep those things in mind. Now, there's no such thing as a glue gap. If you cut your inlay in half and you have a gap at the bottom of the inlay, that's bad. If your inlay bottoms out and leaves gaps on the top, that's also bad. Now, with my plugin, I narrowed it down to exactly one setting that you have to change to find the perfect inlay fit. I call this parameter the inlay fit adjustment, and it's the one thing you will change, and it only affects the plug. When you're creating an inlay, you're going to create the pocket for the female part, and you're not going to change it. You're going to pick an inlay depth, and that's it. And the plug, you're going to pick a plug, some of the plug variables like the plug base thickness and the plug clearance gap. You'll pick those, and you'll not have to change them. You're just going to change that one parameter, and I'm going to show you how to find the optimal one. I use my plugin to create a Fusion 360 file that you can download that will allow you to do these tests for a 15-degree V-bit and an 1/8 of an inch downcut bit. Also list the bits that I use in the description. And it's a very simple test. I made it so that you can use a piece of 8/4 stock wood for both the inlay part, the female pocket part and the male plug part. Okay, this is the Fusion project. You can go ahead and download it and take a look at it. And what we have is just 3 separate inlays. We'll generate 3 different plugs with different inlay fit adjustment values to find the perfect fit. And it will engrave those into the actual female pocket so we know which values we used. If we go over to manufacture, we can see the first one is a pocket first test, and that's going to be engraved in the pocket. And let's figure out the stock size we need by double clicking on it. And roughly the width, about 2 inches, 1 13/16, 8/4 stock. I made it so we could do ingrain and ingrain. About 4 inches deep and about 3/4 of an inch high. The important toolpath notes. I'm going to do things a little bit different. So I added a facing toolpath. So I start with stock that's slightly thicker than what I just was showing, and I machine it to exactly the top. And that way we can guarantee that we have things at the right heights. I also prefer to use the bottom left corner as my origin, and this way everything will be very precise and repeatable, and I don't have to touch anything off. Then we have the VCarve Toolpaths. There is no clearance bit one because this is a very thin one, a very thin test. You could create a thicker test if you want. Now underneath that is the plug pocket second test. It's literally identical. It just does an actual old school engraving for some different numbers to test a second time. And so now I'm going to start by making the female pocket. I go over to the chop saw and I chunk it off a piece of 8/4 stock, just a little bit larger than 3/4 of an inch. There are lots of ways to hold down stock, and I'm going to use double-sided tape. I have a favorite brand that I'll link to in the description. And what I'm going to do is put it on the back, scrape it really tight after I put it on before I remove the backing, and then put it on my table and clamp it down temporarily to really get squished down and get good adherence to the table. If I don't squish it down with clamps and remove the clamps, sometimes it pops off. I ran the CNC operation for the pocket and it did the female VCarve portion of it. I pop it off the CNC table and then I use an X-Acto knife to just clean up any fuzzies or any parts that are kind of stuck in that might cause trouble with the inlay seating. Okay, for the plug, I'm going to talk about some of the changes I made to the default toolpaths that I generated with the plugin. I'm going to expand them a little bit. So one of the things that I wanted to do, just like the pocket, I want to face everything. And I want to face it to the top of the actual stock. So I'll make the plug actually be a little bit thicker and face it to the top of the stock, not top of the model. So my first toolpath here is face to top of stock. And the only thing that's special here is the heights. The top height, the bottom height is stock top. Usually it's model top. And then next, a lot of times when you're doing a cut with a bit, you may need to do it in shallower passes. And particularly if you're doing a deep carve, and this one would probably be 200 thousandths of an inch deep, and doing that all at once might be difficult for your bit, your machine, or just wear things out prematurely. And so what I generated first was a pass that does a lighter pass on the toolpath. And all I did is I right-clicked on my one that the plugin generated, and I did duplicate, and I'm not going to actually do it because I already did it. And on the duplicated one, I moved it ahead, and I'm going to call it the rough one. The one thing I changed about this, if I double click on the toolpath, I'm going to go over to the passes, and the trick to make it do a lighter step down is I left a stock leave of 100,000ths of an inch. And you could do this multiple times. You create one, the first one, say leave 200,000ths of an inch, and then 100,000ths. You can create step downs that way. Radial stock should be 0. And don't change anything else. And what that does, which we can kind of see in the preview, it did a light pass here. It did a light pass here around the thing, and then the next one's going to be deeper. And the same with the clearance. I wanted the clearance to have step downs. Now this is a lot easier because there's a passes tab with multiple depths. Max step down of 100,000ths for my 1/8 of an inch bit. And the last thing to talk about is the order of the tools. So I'm using several different tools. I got a 3/8 of an inch downcut for my face. My V-bit is T26. And then I do the clearance, and then I have to come back and do the rest with the last V-bit. And this might be a lot of tool changes, and it might be better to do the entirety of the V operations before you do this last clearance. Unfortunately, this toolpath is dependent on the other ones happening first because it uses rest machining. But you can actually tweak that and make it happen sooner. And the way to do it is you right-click on it, and you can go Protect after it's generated. Now you can click and drag it above that other one, and now it will do them all grouped. So all the V-bits will group together, and the clearance will be at the end. Okay, for the plug, I'm going to create it 3 different times with 3 different inlay fit adjustment parameters. I'm going to use 020, 060, and 0100, 100,000ths of an inch, and find out which one works the best. So I will go back over to Design, and for the first one, Modify, Change Parameters. I'm going to go find the inlay fit adjustment. I'm going to make it 020 for the first one, hit OK. Go back over to Manufacturer, and notice the pocket toolpaths did not invalidate, but the plugs did because it changed the parameter for them. So I'm going to hit Command-G to regenerate them. And after it regenerates them, I will post-process and save this one as the 020 fit. After I save that, I'm going to go back over to Design. I'm going to do Modify, Change Parameters again, and change the inlay fit adjustment to 060, and hit OK. Go back over to Manufacturer. Again, the toolpaths are invalidated, so I have to regenerate them all. And then I'll post-process this one and save it as the 060 toolpath. And then I'll repeat that again for the 0100 toolpath. And we'll have 3 different plugs with 3 different settings where we can find the one that's going to work the best. In the shop, I cross-cut some pieces of 8/4 walnut, and I made them 1/2 inch thick, and I then went and cut those in half again to have roughly 2 inch by 2 inch plug pieces. For like the pocket test, I used double-sided tape to hold my little plug pieces down, and also like before, I'll scrape the tape really hard to ensure it's really stuck down on it, and I will also temporarily clamp it down to ensure it gets stuck to the table really well. I can then go ahead and run the toolpaths, and each plug takes about 7 minutes to cut in my machine. Granted, I have an automatic tool changer, so that really saves a lot of time. If you are doing something like this and you don't have an ATC, you should probably touch off your tools at the exact same spot again and again on your spoil board. And I highly recommend using your spoil board as your Z0, not the top of your stock. Since my actual stock for the plug was a little bit bigger, I had to go to the bandsaw and cut off the extra pieces. I probably should have sized it a little bit more correctly with that plug profile, and then I wouldn't have had to do this step. Engraved plugs generally don't need any cleanup, so I can go directly to gluing them in. And I just use a brush and make sure that I get all the glue in the little nooks and crannies. This is a very detailed test and has a lot of small bits to it. I'm careful to glue the right plug size into the right one on the test board. So in this particular case, I'm gluing the middle one, was my 060 case. I don't know why I did it first. I glue all 3 in, let it dry about an hour, and then I cut the tops off on the bandsaw, and then I go ahead and sand it smooth on the top so I can actually analyze the fit on the top. At this point, you have to really scrutinize how it turned out and look really carefully. And on my 020 test one, I see some gaps right around here. And so I would guess that it's bottoming out when I cut it out in half and needs a larger clearance value. The 060, it also has a couple of gaps, might need to go have a slightly bigger value. The 0100, it actually has absolutely no gaps, really the tightest one of all, but I have a feeling it didn't bottom out at all. So I probably want to do another test going between 060 to 100, and let's cut them in half and see how it looks. Okay, so now these guys are cut in half. So let's take a look at the 020, and it definitely bottomed out. So it's bottoming out, which is leaving a gap on the sides here. 020, no good. 060. 060 also looks like it's bottoming out completely, and does have a slight gap in some of the cases. It's pretty good, but it could be a little bit bigger of a clearance gap. Probably 070 might be a good number to use, maybe 080. And then the 0100, now this one has a gap at the bottom, which is not good. The interesting thing is this particular inlay and this design seated really far. Really, this one shouldn't have fit at all into it, and it squished down. Ingrain tends to kind of separate, and so you can have a different value when you're doing ingrain to ingrain versus ingrain to face grain and face grain to face grain. So at this point, what I would do is I would do the test again for ingrain to ingrain with this bit, and I would probably change my values to be 070 and 080, and take a look at how they look and find which one fits without any gaps on the bottom or on the sides. Okay, so I did the test again using 080, 085, and 090, and they're all just slightly gappy on the bottom, so that means it's not going deep enough. And I would probably use 070 for this particular case. I could really do it again if I wanted to dial it in and get it just perfect. And that'd probably be a good thing to do. I'd also be pretty confident using 060, which had pretty good results, or just going for 070. All right, so that's how to find the perfect inlay fit adjustment. Okay, I was hoping to do a detailed walkthrough on exactly what the plugin's doing, but this video is just taking too long. So look at the timeline to see what it's doing if you're interested to know more details. I'm hoping in the next video to talk about how to do curved inlays because they're really exciting, and that's really the entire purpose of why I created this plugin. So stay tuned for that. Otherwise, thanks for watching. Bye, everyone.